Today we are going to see heat transfer problem in unit 3, that is the two-dimensional scalar variable. The same problem we have seen in one dimension. It is a two-dimensional scalar variable. Now how the stiffness matrix will be, how the conduction matrix will be, how the convection matrix will be, how the force vector, how the heat flux can be find out. So we will see one problem regarding that. Compute the element matrix, that is element stiffness matrix, and vectors, that is force vectors, for the element shown in the figure when the H23 and 31, this is 31, experience a convection loss. This symbol indicates there is a convection loss. Here the air surrounding is air. Then H is equal to, they are given that everything 10 watt per centimeter square, T infinity fluid temperature, even the K is stiffness 160 watt per centimeter Kelvin, Q naught is given, heat transfer coefficient, everything is given. So what we have to do is that we have to find out the conduction matrix and convection matrix. K is given, H is given, Q naught is given, T infinity is given, everything is given. So now even the coordinates are given. Here the nodes are 1, 2, 3. So let's start to find out here what is the convections in this side and what is the convection in this side. Actually this is 15 watt per centimeter cube Kelvin, and this is, so this side for this it is given H1, 2, 3 convection sides, and this is also convection sides data. This is also convection. The T infinity is same. So because it suffer fluid temperature, fluid air is surrounding there, that is 40 degrees Celsius. So everything is given here. Now we will go into the see, this is the conduction matrix for the conduction stiffness matrix for the conduction. So this is K by 4A, that is stiffness. K is given, that 4A is given, area is given. So B1 square C1 square plus B1 B2 C1 C2 B1 B3 C1 C3. Here B1 B2 C1 C2 B2 C2 C. So this way it is goes. So see here the diagonal. So B1 C1 square, B2 C2 square, B3. So the diagonal are 1 increasing on the whole square, B1 C square, C1 C square, which is, so exactly the highlight. And this element will be in the same here, and this element and this element will be the same, and this element and this element and this element is same. So nothing, very easy to mug it up, nothing to. So this is diagonally see B1 B2 B3, so easily you can mug it up. And B1 B2 here, B1 B3 here 3 comes, B1 B2 C1 C2 B1 B3 C1 C3, here B1 B2 C1 C1, this one, and see B1 B2 here B2 B3 C2 C3 B1 B3 C1 C3. So easily you can mug it up. So this value we have here, the B1 C1 are the x and y coordinates, the coordinates point that we have to find it out. It's an area, you know, x1 x2 x3, because it's a triangular element, so always will have the same formula. So it is that instead A is equal to 12 centimeter square. So conduction matrix, the stiffness for the conduction matrix is given this one. Now we have to go for the conduction matrix and the convection matrix. So this is the convection matrix already seen. This is the convection matrix for 3 sides. This is convection matrix for 3 sides. Here the convection matrix, this and this holds because there is no convection in the 1, 2 side. This side there is no convection is given, so that formula can be neglected. So there is no such convections happening up in the side 1 and 2. So 1 and 2 this, so I have cancelled this and this remains. Now this is the formula. H is given for the side 2 3, for the side 3 1, and this is the length of the element, that length of the side, here the length of the edge. So we have find it out this x1 minus x3 y1 minus x4. So here we are getting s13. So this is s13 is here, this one. So we have to find out s23 also from the coordinates. easily I can find it out the coordinate value. So S32, the S32 value, you got this. Now we will substitute. Now we have to find, first we are find out the conduction matrix. The conduction matrix is value. This is like a Q1 R1. Same thing, Y2 minus Y3, Y3 minus Y1, 1 minus 2. This is exactly opposite of this. So B1, B2 are remaining, that Q1, Q2, Q3, and C1, C2, R1, R2, R3. In that way, same formula, but B and C are different because it's a conduction matrix. These values substituted in the conduction matrix, that B1 square plus B2 square, that B1 value is 4, B2 is 2, B1 value is what? 2, so 2 square plus this is 4, this is B1, B2 value is where? B2 value is here 2, so 4. So in that way you have to find it out. B1 square plus C1 square, in that way 4. We have to find it out, substitute this value, and I got conduction matrix. And convection matrix, now I will go, this side is becoming 0 because there is no convection is given, there is no losses, so I don't want to take up this formula, and I will take this to both the thing. I will find S23 and S31 is, I have find it out, that is 8.25 for the length of the side. This is the distance formula. Using the coordinates, I find out the 8.25 centimeter. Now I find out the S23, that is 3 through or 2 3, that side. So this is 4 point. Now I'm going to substitute this equation and substitute and multiplying inside and adding it up, I get this equation KH. So now conduction matrix we have find it out. For convection matrix we have. Now we have find out the force matrix. The force matrix formula Q0 by A by 3 1 1. Here area you know 1 1 1 1. So F1 negative. F2 side, that is we don't want to find the side 2, that we don't have 1 to 2. That is any convection loss. There is no force. There is no heat convection. There will be no force. So F2 will be 0. So F3 side H32. S32 and H13, S13, 101. See, one thing you remember here, let's see, this you have to remember, H32, T infinity, S32. See, there is 32 is there, 1 is not there. Here 1 becomes 0. So here it is 13, 13 is there. Yeah, 13 is there. So 2 is not there, so 2 becomes 0. So in that way you can mark it up. So in this way I got substituted all this formula. S32 I know the value length of that, S13 I know the length of that, and so I found out, substitute this equation, I got this KC, KH and the force vector. And again we will see, this is the problems completed, and one more thing how to mark it up. See, here you see H12, HS126. Here we can easily see the 3 matrix is not there. So third column and third row put 0 0 0, 2 1 1 2. This, remember this. Okay. Now you see H23 and 3 2. Here 1 is not there. So first column, first row becomes 0. 2 1 1 2. So here 3 1. Second column, second is not, 2 is not there. So second column, second row will become 0. 2 1 1 2. So in that way you mug it up. Mug it for the convection matrix. So this is very easy. Strength of matrix, conduction matrix is also to mug. Be only you mug this, then this all increase that, and this and this are equal, this and this are equal, and this and this are equal. You just mug it up. Okay. Thank you very much.